question one. Before I even answer this question, let me ask you a different question. If I look at the equation V equals F lambda, if I double the frequency, what happens to velocity?
Doesn't change.
Does not change, thank you. If I change the wavelength, what happens to velocity? Does not change. So the only thing that changes the speed of the wave is the medium, or what the wave is traveling in. So if I want to change the speed of sound in air, then I have to change the air, and the temperature of the air will change the density of the air, which will change the speed of the sound. It'll change the speed of the particles, all that stuff. Good? And we have that equation that the speed of sound is 330 plus 0.6 times 10. So those are basically all of the equations for sound that we had. And then remember, a closed pipe it'll resonate at 1/4 of the length of the wave. An open pipe resonates at 1/2 the length of the wave. So make sure you have all that somewhere written in your notes with your equations. So then number 2, which of these waves is fundamentally different than the others? So I have radio waves, sound waves, light waves, microwaves. Sound waves. Sound waves are fundamentally different than the rest because sound waves are mechanical waves. They require air molecules or some other sort of molecule to move around, right? Radio waves and microwaves are light waves. They're all the same. They're the same thing, right? It's just that radio waves and microwaves have different frequencies, different energies, different wavelengths, however you want to think of it. But they all carry their own medium. They're all electromagnetic radiation. They're all light waves. Good so far? All right. 100% maybe, I hope. Okay. Now this one, singer can make a wine glass break using the concept of resonance. That was in that video that I told you guys you should watch. It's actually worth going back and spending 20 minutes of your life to look at it. And it's fun, and you get to see the Tacoma Narrows Bridge. And Ella Fitzgerald, you can gain some culture, right? Do you guys know who Ella Fitzgerald is? No. Famous jazz singer? Strange Fruit? Yeah, Strange Fruit is like one of the great jazz songs. So totally depressing because it's about lynching, right? But all right. Anyway, light travels fastest in a vacuum. Because it has its own medium. If you try to make it go into something, remember it has to get absorbed, re-emitted. So it actually travels fastest in a vacuum, and then next fastest in hot air because it's less dense, then cold air. And then it travels slowest in glass on that list, right? And we didn't really get to talk about it. Well, and maybe, depending on what you guys choose, it travels slowest in diamonds, as far as we know. There could be something it travels slower in, but as far as we know right now, it's diamond. Sound waves. Sound waves are transverse waves or longitudinal waves? Yeah, they are longitudinal waves, so this would be false. Remember, they're compression waves, longitudinal waves, and compression waves or longitudinal waves are waves where the material is getting moved parallel to the direction of travel, and in a transverse wave, the material is moved perpendicular to the direction of travel, right? And so if I go on to the next question, transverse waves, materials move perpendicular to the direction of travel of the wave, so this would also be false. Good so far? All right, so on tomorrow's test, you guys, there will be 20 multiple choice questions, right, 2-0. And there's only going to be 4 problems. So
you mean four free response questions?
Yes, 4 free response questions.
Oh,
right?
good. That's less than the 7. You know what I mean?
Yeah. Well, usually we have 5, right?
Yeah.
So usually we have 5, and then I have like your bonus question, where I'll ask you like, who's your favorite actor or whatever. I don't know. This time I might have to ask, what's your dream summer vacation spot?
Hey,
Did I already ask
You
that?
asked like 2 times.
Oh. Then I didn't ask it 3 times, did I?
No.
No, I don't know. I was just thinking because the
You,
seniors.
you always say I've been told this is a normal year many times.
No, I don't.
What am I
think
typed to that?
I don't think
Yeah,
I
you
told
do.
you that.
Yeah, you did.
I haven't even.
Always.
No.
Literally always.
No,
Not ever.
No, I don't think ever. No, not ever. But I have been told this is not a normal year. That is something. So anyway, all right. Here's our problem. Problem number 1. So this is going to be a 2-step problem. I'm given the temperature, and the temperature is 5 degrees Celsius. So we're out there on a cold day. I shout to my buddy, and they hear my voice 0.75 seconds later. All right? I want to know how far away are they? So what's the distance? Now, in order to get the distance, I'm also going to have to get the velocity first, right? So I'm going to use this equation. Velocity of sound is 330 plus 0.6 times the 10th. And then I'm going to use V equals V over T, right? So those are my 2 equations. So let's plug this in first. Speed of sound is 330 plus 0.6 times 5. So that's going to be 333 meters per second. Then I'm going to plug it in over here. So this will be 333 equals the distance divided by 0.75. So you guys know you could cross multiply these. You'll end up with 333 times 0.75 in the very end of it, and that will be what? 249.75. And I'm running out of space, so I'm just going to write 249.8. And the units there would be meters. Now remember, if it was an echo, then you would have to cut that time in half. So if I said, like, I'm shouting and I hear my own voice 0.75 seconds later, how far away is the cliff or whatever? My voice would have had to travel there and back to me, right? So if you gave me the whole distance, that would actually be incorrect, because you would give me the distance there and back and not just there. Does that make sense, you guys? Okay. Not that I would do that on a test, but maybe.
You never know.
Yeah, I don't, right, I don't know. I have temporary amnesia. So, I do know the guy who wrote the test, but yeah. All right, so anyway, then this would be typical. Now, I changed this question up for you guys so that it would be more like the test. On the test, it just said, what is the wavelength of a light wave that has a frequency of 10,000 hertz, right? And you know automatically the velocity of a light wave is 3e8, or 3 times 10 to the 8, or 300 million, however you want to think of it. All right, so that's the speed of the wave. Now the frequency of the wave here is 10,000, and I'm going to write that down as 1e4. All right, so or 1 times 10 to the 4th. There's a method to my madness. It just makes the math easier for me. All right, so I just put it in scientific notation. And remember, that just means I moved the decimal 4 times to the left. And what I'm looking for is I'm looking for the wavelength. So when I do V equals F lambda, right, I'll have 3 times 10 to the 8 equals 1 times 10 to the 4th times the wavelength. So you would just subtract the 10,000 from each side. Or did I say subtract? I meant divide. Thank you. So those go away. And then the wavelength is going to end up being 3 times 10 to the 4th, or 30,000 meters. Right, because then I could just subtract the exponents. That's why it's easier for me. Otherwise, I might lose track of all the zeros and mess it up.
Yeah. Yeah. When you put 3, 4, you know there's 4 zeros after it.
Yep, you could put 30,000. You could put 3 with 4 zeros. So it's literally the same number. Or you could write it as 3 times 10 to the 4th. Once again, literally the same number. It's all the same. Same. And in college,
test.
right, in college, if you wrote it down as 3e4, your professor will not be happy with you, right? But I'm okay with it because it's just, you're just writing it down off your calculator.
You're not comparing us to college.
But I am, trust me. All you would have to do is change that times instead of E, just write times 10.
You're setting us up for failure. Come on.
I'm not. Trust me.
Everything right, then we'll write it like that. We'll lose the whole thing.
That would be a really mean professor. If they didn't give you partial credit, no, they're not all mean.
That's the way movies portray it.
Yeah, no, they're not all mean. In fact.